Assalamualaikum and good day. This is part 2 of videos on heat treatment of ferrous metal. In this video, we will look at the first type of heat treatment, which is annealing. It is a heat treatment in which a material is exposed to an elevated temperature for an extended time period and then slowly cooled. When it should be done, annealing is done between process steps to allow further working or for final stress relief. You can see there are two purposes of doing annealing. The first one to allow further working. The second one is for final stress release. There are three stages of annealing. The first step is heat to specified temperature, hold or soaking at that temperature for specified time, then cool slowly, usually to room temperature. These stages are applicable for all heat treatment under annealing. There are two types of annealing. The first one is process annealing and the second one is full annealing, as we can see over here. Please remember, time and temperature are important at all three steps. So what is the purpose of annealing? The first purpose of annealing are relieve internal stresses. Internal stress can build up in a metal as a result of processing, such as welding, cold working, casting, forging, or machining. If the internal stress are allowed to remain in metal, the part may eventually distort or crack. Annealing helps relieve internal stresses and reduce the chances for distortion and cracking. The second purpose of annealing is increasing softness, machinability, and formability. A softer and more ductile material is easier to machine in the machine shop, and a nail part will respond better to forming operation. The third purpose of annealing is refinement of grain structures. After some types of metalworking, particularly cold working, the crystal structure are elongated. Annealing can change the shape of the grain back to the desired form. The first type of annealing is process annealing, a heat treatment used to soften and increase the ductility of a previously strain-hardened metal. Strain hardening usually happens due to cold working. In process annealing, parts are not as completely softened as they are in full annealing, but the time required is considerably lessened. The steps for process annealing and full annealing are the same, it's just the time required for process annealing is much lower than full annealing. Process annealing is frequently used as an intermediate heat treating step during the manufacture of a part. So what is the purpose of process annealing? It is done to treat parts made out of low carbon steel, which are less than 0.25% carbon content in the iron, which allow the part to be soft enough to undergo further cold working without fracturing or without fracture. Commonly employed for wire and sheet steel because it restores the ductility to cold work material, and permit further cold work to achieve the required deformation. Internal residual stress may develop in metal due to plastic deformation process. It occurs while machining and grinding. Internal residual stress may also develop because of non-uniform cooling of a piece that was processed or fabricated at an elevated temperature. For example, while doing welding, where high temperature is involved, or casting, also high temperature involved. Distortion and warpage may result if these residual stress are not removed. So what is the procedure on doing process annealing? So the process on doing process annealing, the first is heat to below upper critical temperature. Upper critical temperature is A3 line. You can see in this figure. The heat up temperature is about 500 degrees Celsius to 650 degrees Celsius to cause recrystallization of ferrite phase. After that, we cool it down very slowly in still air. In this figure, you can see process annealing occurs here. The heat up temperature is around 500 to 650 degrees Celsius. It is below upper critical temperature and also below lower critical temperature or A1. Microstructure produced is fine grained structure. Structure will now be equiaxed per light. It is used to maximize the ductility of low carbon steel and other material after cold working. The second type of annealing is full annealing. It is used in low and medium carbon steel to improve the properties of cast and forged steel prior to machining or before machining process. The process or procedure in doing full annealing is heat the steel above austenite temperature, either 15 to 40 degrees Celsius above line A3 for hypoeutectoid to form austenite, or line A1 for hypereutectoid to form austenite and cementite phases. After that, cool very slowly in furnace. The cool down procedure for full annealing is much slower because it needs to be cooled down in furnace. Meanwhile, for process annealing, the cool down is in still air, where the temperature drop much faster compared to when cool it down in furnace. In this figure, you can see over here is eutectoid. It should be around 0.76 to 0.8% of carbon content. This region over here is hypoeutectoid, and this region over here is hypereutectoid. For hypoeutectoid steel, you need to heat the material 15 to 40 degrees Celsius above A3 line over here, which means you need to heat it up around here so that the microstructure will form austenite. For hypereutectoid, you need to heat it up above A1 line over here. A1 line is lower critical temperature. It is slightly above eutectoid temperature. You need to heat it up until the microstructure form austenite and cementite phases for hypereutectoid. Microstructure produced from full annealing process is structure will now be large grain coarse perlite where the properties are soft and ductile. For hypoeutectoid and hypereutectoid annealing, for hypoeutectoid steel, which is less than 0.76% of carbon content, are heated above upper critical temperature or above A3 line, and then it's soaked at that temperature or let it be at that temperature and then cool slowly. The soaking time is occurs until all the microstructure turn into austenite, and then we can cool it down slowly. For hypereutectoid steel, where the carbon content is 0.67%, are heated above lower critical temperature or above A1 line, and then soak it up until it change into austenite and cementite phase and allow to cool slowly. There is the procedure or process of annealing for hypoeutectoid and hypereutectoid steel. That's all a little bit on our first heat treatment, which is annealing. Please remember we have two types of annealing, which are process annealing and full annealing. We need to know the purpose of this heat treatment and then the process of this heat treatment and then the microstructure that we get after doing this heat treatment. I really hope you can do the summary in table like this so that you can easily understand this first heat treatment. So until we meet again in the third part of heat treatment of ferrous metal, where we will look at normalizing. Thank you and have a good day.